Okay, so we're going to do a basic sketch here where we're going to draw a picture and we're going to remember a few things about processing that you may have forgotten over the summer. So we're going to start off. There are two functions, which that word already might jog your memory of things. There's two functions that processing sketches usually have. They start with the word void, is what you might have even called them voids last year. I didn't correct you too hard on that. But the proper word is functions. Do you remember there was like void something, void something? What were those two voids? Say it out loud. Yeah, Mark. Yeah, setup and draw. Void, setup. And void is a bit of a long story, but we'll talk more about that this year. It's called its return type. So setup doesn't return anything. It's just a list of things to do. And functions, we explored these parentheses last year, but for the most of last year, they were just two random parentheses you just typed in, open and close. We started learning about how we could use those at the end of last year. We'll use them more this year. And then we have the braces. Oh, the braces. The ongoing joke that I kept on trying to make funny was we have more problems with braces than an orthodontist office, but it never really, it made me funny the first time, but I think I told it like 100 times. This is the curly bracket, as you might have called it before programming. Now it's called the brace, now that you know about it. And it's just right beside the letter P on your keyboard. P for processing, and there it is, the brace. This denotes a block of code. So when you're starting this function, for example, what is the contents of this function? Like what code is going to go inside of it? Well, the braces start the beginning and end of that block. We'll see that as well with if statements and loops. When we want to say, this block of code is what happens if this is true, we use the braces to do that. But you know what happens? We'll forget our brace at some point. We'll delete one by accident. We'll be copying and pasting and forget to grab a brace. And then, oh man, it gets tough. So watch out for braces. The other function is void draw. Draw, there we go. And whoops, I screwed that up too. There we go. Void draw is the other function that we need to do processing. And this is one of the things that differentiates processing from Java. Pure Java doesn't have these. They have something called a main function or method. But we have these things instead. So tell me, everybody, what does this, and you can just raise your hand if you got an answer to this, what does this function void setup do? What's its purpose? And when does it happen? When does it occur? Thanks so much, Sloan. Yeah.
Like at the very beginning of the program.
You got it, yep.
It just sets up all the things like size.
Perfect, you got it. So yeah, exactly that. The purpose of the setup function is to set everything up. Well named, isn't it? It happens right at the beginning of the sketch, which is the name for a processing program, by the way. And it never happens again. So it just sets things up for you. So things like the classic thing, as Sloan mentioned, was size. Size gives you a graphics window, and you can choose its width and height. So if I say 600, 800, and then semicolon, by the way, every line of code that is like a command inside of a function ends in a semicolon or a brace. So that gives me a graphics window. So I'm just going to put a little comment. 2 slashes, by the way, the forward slash down by the question mark gives you a comment, and I'll just mention that this is width, comma, height, just to remind ourselves. Notes or comments, by the way, are things that are ignored by the computer. They are not used by the computer. It just lets you type a little note for yourself to remind yourself of what's going on. They're very useful for all sorts of things, not just for yourself, but if you are coding in a team, for example, which turns out how all software is made out there in the industry, just about every, and maybe Stardew Valley might be the only one, or a couple other pieces of software, but usually you're making it in a team, so these comments are there for your teammates as well to understand what you're doing. So that's size. So technically this is a complete program. We can run this, and we'll look at the amazing thing that happens. How do you run the processing project? There's a little play button at the top. It's just a little circle. Oh, that magnifier's in the way. Just right above your tab there, it's a little play button. You can press run, and it'll start chugging, and out comes this graphics window. And it's oh yeah, I guess that's correct. I was like, wait, it's long. Oh wait, no, that's what I typed in. I said 800. So there it is. That's apparently 600 by 800 pixels, and that's where my program would start unfolding. Had I done anything to make a program unfold. So yeah, there you go. So that's set up. Draw. What's draw do? What's the purpose of draw? That's kind of a long story. Maybe before that's a bit too big. How often does draw happen? Optimally, if everything's working out smoothly, how many times is draw happening? Thanks.
15 times a second.
Did you say 60 times?
Well, it depends what you're...
Oh, that's a really good answer. Oh, good answer. Yeah, so it's going to happen optimally. It's going to try to happen 60 times per second. That's what if everything's going smooth, whatever code you put into the draw function will happen 60 times in a second. So whatever code it is, it'll happen. I can't flash that fast, but it'll do it that many times in a second. But Ashton's right. If you are running a program that can't seem to get done in 1/60th of a second, then it'll start automatically adjusting that pace. So it might happen at 50 frames, 50 times a second, or 1 time a second, 1 time every 20 seconds if you really mess something up. So that is often in teenage experience called frames per second. Maybe when you're like running your Overwatch game and you're trying to run it at full ultra settings or whatever, and you can run it at 60 frames per second, and you're like, oh, my computer's so good. So it's a similar kind of concept. All that stuff that makes that happen is all under the hood, and that's all something that processing gives us, which is really wonderful. It also has this concept called double buffering, which we won't get into, but that's all sort of built into processing as well. And if you were to do this in pure Java, you'd have to do those things yourself. You'd have to create the graphics window and create a canvas and create this timing system to show it and all this kind of stuff. So it's really nice that it gives us that. Everything else, though, is pretty much pure Java. So what could you put in the draw function? Well, you could draw some stuff. So I'll draw some really basic stuff just to remind you about the commands at your disposal. And then it'll also remind us about the XY axis and how it's weird and different than math and layering and that kind of stuff. So we'll just go through it fairly quickly, but do ask questions as we go. So the first command I'll remind you about is background. Background I won't call them commands, but it's actually, that word is interchangeable with the technical term, which is a function. And you might wonder, what's the difference between this function and that function? Well, here we're calling a function, we're using a function, and when you say void setup or void draw, we're defining our own function. So there's a bit of a difference here. So I am calling an existing function called background. It's built into processing, and it takes a parameter, which is just a number or something, it could be a word, that will change how it behaves. And that number is a number between 0 to 255, which will be a shade of gray. And last year's joke was how many shades of gray are there? And people are like, there's 50 shades, because that's a terrible movie. Or maybe it's good. I haven't seen it personally, but I've heard it's pretty bad based on Rotten Tomatoes. So no, there's 256 shades of gray, starting at 0, going to 255, and we wanted to see that movie where some kind of programmer, I don't know, we don't really want to see that movie, actually. Just leave that alone. But anyways, so if I put in 0, I'll get black. If I put in 255, I'll get white, and somewhere in between gives you a shade of gray. Closer to 255, the brighter it is. So I'll put a comment, 0 is black, 255 is white, and you can figure it out somewhere in between. So that's one option. And by the way, anything that we're going to talk about that is a color, it can be defined either that way or with 3 numbers. So if you give 1 number, it's a shade of gray. If you give 3 numbers, it's going to be an actual color from the rainbow. So I'll show you. So I could do background with the color from the rainbow, but instead of making you retype that, I'll just give you another example where I use 3. But just know that you can use either 1 number or 3 number anywhere you're talking about colors. So here's another example. Maybe quickly I'll just draw a shape before I do a color. I'll do the ellipse. It was one of our favorites from last year. I think we used this in pretty much every project. There was not a project where we didn't use the ellipse. And it draws a circular-like shape, possibly elliptical, depending on what kind of numbers you use. So this requires 4 numbers, the x and y location of the center of the circle or ellipse, and then a width and a height of the ellipse. And it's a little bit confusing because the origin, 0, 0, is not in the center of your graphics window. Where's the origin in our graphics window? If I run it, where is it? What corner? Top left, you got it. 0, 0 is actually at the top left of the screen. And X is fine. As you increase, X will go across, going to the right, just like in math. But strangely enough, as you increase Y, you actually go down the screen. And the reason for that is because, and this is for all computers, by the way, all computers are set up this way. It's because they didn't want to use negative numbers in describing coordinates on the screen when graphics were a thing. Actually, the first screens were circular, so they didn't even use X, Y, these polar coordinates. But whatever, don't worry about that. Once they made rectangular screens, they were like, oh, it'll be so annoying to have negative numbers and positive numbers. Let's just make it all positive. They want it to be positive. Hey, who can blame them? So that's why that's a thing. So what are the coordinates of the center of the screen? Hint, here's the size of the screen. What's going to be the center coordinates? Thanks, Sloan. Yeah, it's basically just divide these by 2. So the center of the horizontal will be 300. The center of the vertical will be 400. So I'll put an ellipse here. I'll say 300, 400. And how big should we make it? Yell out some numbers. Make it visible. 100. So that's going to be width and how tall? 45. Bold choice. So just to remind you, especially if you're new, this is X, Y, and then width and height is basically what the order of those numbers are. If you're new to this, or if you're just like, oh yeah, what's all this stuff? A lot of the early parts of this course were of Programming 11 anyways, the previous course. We're just learning like what are these function names and what numbers do I give them and in what order in order to produce things. So many of you have already like internalized that. You didn't need me to tell you that this morning, or you're gonna like quickly remember them as we get going. What were some other functions that we had for drawing? Just yell them out. Rect. Get rect was our joke from last year. It's so bad. A rect makes a rectangle, and it's just R-E-C-T. Kind of similar. It was a little bit different, but mostly the same as ellipse. What else? Triangle. Yeah, we made those majestic mountains in our animation project that traveled across the screen. What else? Line. Thank you. That's great. Lines are so good. We made a grid, like a graph paper simulator or like creator or whatever. That was fun for lines. Any others you remember? Yeah, we didn't use too many others actually. Huh. We did a lot with just those simple shapes. Anything else you can think of? Yeah, image. Yeah, we can draw a picture we download. We kind of gave up on shapes after we could do that. We're like, what do we need that for? So that was good. I guess there's arcs as well. Poly is another one where you can make like many-sided shapes. There's a few others. Yeah, so there we go. So if I run this, we'll see an ellipse at the center of our screen. So lovely. It is center is located at 300, 400. Its width is 100. Its height is 45. I'm offended by that for some reason. I'm like, no, it's got to be a circle. As long as it's going to switch that to 100. Sorry, Xavier. You had a good number there, 45. But I just can't handle it. Okay, hey, what if we wanted to color this thing? What if we wanted to change its color? What if we wanted to make it look like something else? Thanks, Lo. What do you think? Fill. Yeah, we got some fill. We're going to change the interior color with fill. And we change the outline with stroke. You got it, stroke. Stroke is a weird word, but that's the industry term for these things. I don't know why they chose stroke and not like outline or border or something, but it's just called stroke. So where do I put this? Do I draw the shape and then fill it? Yeah, I got to fill it first. So people are like, wait, what? Why do I fill it and then draw it? So fill, think of it as selecting your crayon from the crayon box. And stroke, same thing. You're selecting the crayon from the crayon box, and that's the current colors you're going to use. So every shape you draw after a fill and stroke, you're going to use those crayons that you selected. So that's like the metaphor we tried to do, but it's still confusing. So you type in fill, and this time I'll use 3 numbers. Just to give you the comment, it's red, blue, green. And that might be hard. You're like, oh yeah, I wanted fuchsia. Well, you know, I wanted a seafoam green. Like, what are those colors? Well, we won't worry about that in a second. But if I said 255, 0, 0, I will get like the reddest red that our hardware can produce. Like it'll be red. Like there'll be no doubting about this. It'll be definitely red. For stroke, I can do the same thing. Gosh, I'm scared to, what color can we do with this? Let's do blue, I guess. 0, 255, 0. That would give you the bluest blue that ever did exist, according at least to our hardware that we have here. Yeah. Oh, did I say RB? Oh, yeah, you're right. Thanks. 10 points to House Gryffindor. Green, blue. Thank you, Mark. Sorry, I screwed that up. That is correct. It is red, green, blue. Absolutely. Okay, so that will produce a green outline. So it's like Christmas. And then last but not least, I want to remind you about stroke weight. Spell like that with a tricky capital W in there. Stroke weight changes the thickness of the stroke. So if I put in 10, for example, it would be 10 pixels thick stroke. The default is just 1. So if you normally were just programming, didn't choose a stroke weight, it would be 1. Check out my beautiful circle. I'm going to run this. Ooh, look at that. Isn't that glorious? So good. So good. Aren't you glad you took Programming 12? Learning all these advanced techniques. So that's good. So a couple things about, maybe I'll do another shape while I'm at it. What other shape should I do? Rect. We're going to do a rect. So rect is for rectangle. It is spelled R-E-C-T. Why didn't they make you type the rest of it? I'm not too sure, but I guess it's kind of convenient. I'm going to make it at the same place, 300, 400, and I'm going to make it 100 by 100 as well. So these things are the X and Y, again. X, Y, width, and height. So it's got the same parameters, the same numbers. They mean the same thing, but you'll notice it's a little bit different. Some of you already know what's going to come here. So just kind of imagine, what do you expect to see? Well, it turns out you get that, which might perplex you because you might be like, wait, they have the same centers, so how come they're not like, why isn't the square in front of the circle? Like, why isn't it covering it up? So that's the annoying thing about rect. Rect, the center isn't the center. It's actually the top left corner. And you can see that they're lining up. At some point in beginning programming, you discovered that you can actually change that with rect mode and ellipse mode. So you can actually modify that manually and just like change where the center is. But we didn't have enough. It was just, you couldn't learn everything on the first day, right? Or in the first month. So we had to unfold that information as we went. And it kind of made for an interesting challenge to get all that stuff going on. Notice that they're both red and green, right? So the same fill and stroke applies to every shape that you go all the way down the road. If I was to take this here and let's say I wanted a different fill and stroke for my rectangle. So I'm just going to copy and paste this. And I will keep stroke weight the same, just to demonstrate. And I'm going to paste in the fill and stroke, and I'll change this. I'll make it blue. And what happens when we mix red and green? What do we get? Let's find out. It's different than in paint. Light mixed differently. So I'll do this. So what do you expect to have happen? So hopefully you'll think, okay, so we selected these crayons and then drew an ellipse. And then we selected these crayons and we drew a rect. So these will apply to the rect and these will apply to the ellipse. So is that true? Let's find out. And let's find out what 255 and 255 is. It's yellow. What? Red and green make yellow? That's definitely different than in paint. Have you ever mixed paints together? I don't think. Is that, or am I wrong? I don't do too much painting anymore. My kids used to do finger painting. I kind of gave up. Ooh, but look at that. Look at this drawing. So good. There it is. Hey, here's a skill testing question. This one's a toughie. What if I delete this? Don't say it out loud. Just let people think for a second. If I delete the first set of crayons, what's going to happen? Just think about that for a second. Okay, let's run it. Let's see what happens. Wait, why are they the same? I selected no crayons. And actually, if I put in, I put no loop in here, which means the draw function doesn't happen twice, we will see that the circle was originally like the default color, which is fill white, stroke black. So why is it, and there's the hint about the loop, why is it that the circle turns blue and apparently yellow? Put in stroke weight here. Any takers on that one? Why did the circle turn blue? Yeah, Mark, you want to go for it? Thanks, Dave. You got it. Yeah, so you have to remember that the draw function is happening every 60th of a second. Hopefully it's happening that way, right? So this code is happening once, and then twice, and then 3 times, and then 4 times, and so on. And by the end of a second, it's happened 60 times. So if you say, I'm going to pick up these colors here, then they are going to apply to the next frame as well. So if I don't say what the colors are for that ellipse, then the first frame it'll draw it as white and black. But that's for 1/60th, that's hard to say, of a second. You're not even going to notice that with your human brain running at human speed with like simple things like electrons, or no, not even sodium, potassium gates moving around in your brain. So you're just not even going to notice it. So this color will then wrap around and draw for the ellipse as well. So we occasionally got problems with that. So I'll put that back the way it was. I'll just use Control Z to get back to my more magical colors here, I thought anyways. I mean, technically, yellow's not in Magic the Gathering, but we're pretty close to having all the colors. Let's see. Oh yeah, and what happens if... Welcome back, Arthur. It's all going to be on YouTube for you. What if I take that background and I cut it from the top and I stick it at the bottom? What are we going to see? We'll see just a white screen. Background was poorly chosen as the name of this because it doesn't color the background. It just draws a big rectangle over the entire width and height of the screen and fills it with whatever color you put in there. So that can be good and bad. Maybe you want to block out stuff, but generally, you have to say background first, and that's always a good thing to remember. How are we doing out there? You guys doing all right? Yeah. All right. There we go. I mean, this is as far as we got last year. This is as far as we covered last year in our first thing. So I think we'll probably stop there because what I really want to make sure you can do is get this into your GitHub account and do a commit. So hopefully you've been typing this up. If for some reason you encounter some kind of problem, or maybe it's, you don't have your GitHub account, you might have some trouble. But I'd like to demonstrate how you will get this code into your GitHub account. You're going to make something called a repository, and then you're going to drag and drop it in there. Okay? If you didn't get to make a GitHub account, maybe I'll just give everybody a minute just to regroup, find your GitHub account, open it up, log in. And if you didn't get one earlier, you can go and do that right now. I'll just leave this video recording. We'll get a giant, huge 600 megabyte file, and I'll upload that to YouTube and crush the school internet for a few minutes. So go ahead and do that. If you couldn't log in before, you couldn't get an account, try now. And if you did, then log in with that account at GitHub. And I'll show you how to upload that code. Arthur, you're probably going to have some trouble doing this right now, but that's okay. Just if you didn't get to, go to github.com and make yourself an account. It's repository. Yeah, we're going to make a new repository. But I'll get into that in a second. Don't go too fast. This is a setting we have to make sure it gets sucked up. So hang in there. Anything did it work better this time? Oh, you already made it. Oh, great. That's good. Okay, so you logged in? Not yet? Oh, you are logged. Okay, great. Thank you. Okay, folks, so I'm going to show you how to do a upload to GitHub. This is your first time uploading something. This is like you're going to look back at your GitHub account. Like, I anticipate GitHub being a thing for many, many years to come. It just seems so embedded. I mean, Microsoft bet $7.5 billion on it, right? Like, that's a pretty serious bet. You know that they think this is going to be a thing. So, so how do you use it? So let me go to my GitHub account, and let's see. Maybe if I go, I think this is fine. It's probably similar to what you see. You might see a couple other things that I've closed that are sort of welcome, and these other kind of things that show up. So the first thing you want to do is, if you're uploading a new project that you haven't uploaded before, you have to create a repository. Usually people call them repos in the software industry. A repository is basically a home for a project. Once you've made a repo or repository, you don't have to make a new one every time. You just continuously add to the same repository for that project. So think of a repo or repository as a project. And I think that explains pretty much everything. So let's see, how do you make a repository? If I go to the little plus icon up here, there's a new repository that I can add in. So far, so good, right? So first of all, you're going to give it a name. And for projects in this class that we do together, you're going to want it, we're all going to use the same name for the repository. So this is a place where you could go wrong. The reason why we want to do it is because when I check your work, I don't want to guess if you called it Ping Pong or Pong Ping or Kim Chong Ping, or I don't know what you're gonna choose for your name for your project, but please, we gotta choose a name that we could all recognize, and then I can find it in your project. So maybe call it table tennis, and I'm like, oh no, I don't know what, or worse, you call it some nonsensical name like dumb game or something. I don't know, I'm not too sure what the. So we're gonna call ours today, and this is not a big deal for this project. I'm not gonna be checking yours. I'll only be checking in the sense that I want to make sure you did it and were able to do it. So I'm gonna call mine review. Wait, what's a good name? Should have thought this out before. Review 1. Oof. No, that's pretty lame. Anybody got a better suggestion for me? Because, I don't know. I don't want, your employer to be, looking through here and be like, oh, man, you can't. No, I'm just joking. They're not going to care. Maybe I'll go Prog 12, review 1. What do you think? Oh, whoops, I already made it. Oh, well, there you go. I guess I chose the name, so that's good. I made this repository, so I shouldn't have done that. Let me go delete it. Hold on. Oh, yeah, I already did make one. Here, I'll delete mine. Settings. And the reason I want to delete it is because I want to show you all the way through exactly how this works. Scroll down, delete this repository. Please type the name of the repository. Okay, Proton Review 12, Review 1. I understand the consequences. Delete this repository. Wow, they really want me to be careful about that. Okay, sorry folks, let's try again. So I'll go back to make a new repository. And I'll zoom in so you can see. It's going to be Prog 12 for Programming 12. Review 1. And then I can make a comment. It's optional, but we might as well put in a description there so we can remember what the heck this was. So this was day 1. You can type what you want to hear. Day 1 of Programming 12. Remembering how to use processing. That's what I'm going to type in there. You can type in something else if you wish. Just make sure you do put in, for the repository name, Prog 12 Review 1. No spaces. There's one more setting that's really important. I guess there's a few more. Public, we're just going to leave that public. That way I'll be able to visit it. And technically so will other people. And by the way, I'm going to be linking my repositories as I save the code as well. So you'll be able to see the stuff that I do. And then, this is really important. Don't skip this step, even though it says skip this step. But we're not importing anything, so we want to initialize this repository with a README. So do check that off every time you make a repository. It's not that we really want a README file. It's basically just a text file with some, it could be instructions or whatever. But it sets it up really nicely so we can just immediately start adding stuff to our repository. And there's a few other settings. So if you wanted to make, if you're putting something out for commercial purposes, you could set a license agreement. Maybe, maybe you're using other software, so you could link it up at that point. But we're not going to do any of that this year. So I'm going to go now and click the big green Create Repository. And, wow, we did it. We made our repository. It's got a README file in it. And we're now going to add our processing file to it as well. So there we go. This is the README. So to add our processing projects that we've been working on today, first of all, you got to save it on your own computer. So that's great because you'll have a backup copy on your local machine. So it can't go wrong there. So I'll do that. And I'll just remind people, how do you save on your local machine? So where do you save your projects and files and all that good stuff? Here on your desktop. On your laptop, I don't care. You can do whatever you want. But on the desktop, where do you save? Documents folder. You got it. Don't save on desktop, although it'll be less of an issue this year because you're backing everything up to GitHub. But if you save on your desktop, every once in a while, everyone on your computer, all 7 or 8, I guess, total students who are saving stuff on the desktop, as that gets to a certain threshold, the computer automatically wipes out everything on everybody's desktops. So we've had students lose their entire project. Like, what? I thought it was okay to save on the desktop. And I'm like, but I told you like so many times. But hey, now we have GitHub. So it'll be like, oh, I lost a project. Ain't no thing. I'm just going to go download it from GitHub. So it'll be fine. So either way, you might as well set yourself up for success and save to your documents folder. I'm on my laptop, so I don't have, well, I guess I do have a documents folder. I guess I'll just save to my documents folder. I don't know what's in there. That's not normally where I save. Oh, apparently I do. I already saved it. It's in review 1. So you go ahead and just save it, and you can name it locally whatever you like. The default is this random like sketch and then the bunch of numbers. Did you know that the numbers are today's date? Wow, hey, it's year 2019, and then I guess it's September 9th. And then the A is like the first thing you save on September 9th, 2019, and then it gives you a B and a C and a D and so on. That's terrible. Don't use that. That's like the worst naming. Like name it something. I mean, it's hard to name this one. Like what is this? I called mine Review 1. So you can call it whatever you want. I think I already have something in there called Review 1. So that's fine. So I'll just save it. So now I can go and once you've saved it, you can go drag and drop it into GitHub. And if you have many, like remember our RPG project or our Pong project, Brick Breaker, all those projects have multiple files. So you can drag as many files as you want at once. We only got 1 today. So you just got to go and navigate your Windows Explorer to that file. So go and find your file. So I'll just press Windows E on my keyboard, and I'll see all my files. I'll go to my documents. Oh, what? H drive not available. Wah, wah. Okay, so I am going to save to my desktop because apparently I can't access that. So I'll just call it Review 1 on my desktop. Let's try again. So you just got to find that Review 1 folder. So mine apparently is on my desktop like you're not supposed to. And now that I have it right here, see that right there? There's the processing file, Review 1. Well, it won't say PDE probably on yours, but it'll have that little processing icon there. If you have that, you're good to go. That's step 1. If you found where your project is saved. Oh, also, I guess I could have just told you, there's a shortcut to get there. Control K. So in your sketch, you can just press Control K and it opens up where it's saved. Oh, I'm so dumb. See, I need review. I need help too. So yeah, you can just press Control K from processing and it'll show you where your sketch is saved. So I like to take that and I grab the window with the mouse and I slam it into the other side of the screen. And then I can choose another thing to be side by side with it. So I'll choose my GitHub page. So I got my 2 things split screen. You can also use Windows and the arrow keys to organize your windows like that. It doesn't really matter how you do it, but just get them kind of both on the screen at the same time. And then for GitHub, what you'd like to do is create a new file. So, or is it create a new file? Let me just double check. Oh no, sorry, it's not create a new file, it's upload files, which unfortunately is just hiding below there. Maybe on your screen resolution was okay. But we want to choose upload files. If you wanted to type something, you could actually type processing code in right there if you wanted. But I'm just going to upload files. And check it out. It says drag files here to add them to your repository. So let's click and drag, and it will get uploaded. And now, if I go back to my repository, there's my README file. Oh, wait. Oh, no, sorry. I screwed up. You got to do a little bit more work. Let me go back. I didn't actually finish. So upload files, click and drag it over, and you actually have to press the green button, commit. And you can add in some text to remind yourself. Like if this is like the third or fourth time you're dragging and dropping this in, you might want to say like, what did you add new to this particular one? So I'm just going to say the beginning of a beautiful project. ... That's going to be the name of this commit. And then future commits, you could say, added in the mode framework, added in the pause screen, whatever it is you commit and add in, you could document that. So now that I've done that, there we go. Now I'm going to click commit changes, the green button. There's some things about branches we won't talk about today, but you can split it. So you can maybe you're trying something new and you don't want to break the old thing. So you split it and you make a new branch and try your new thing. And if it works, you can merge it back. Or, if it doesn't work, you can rewind and go back to where you didn't break your project. But right now, we're just going to always commit directly to master branch. And there we go. I'm going to save it. Processing your files. How good is that? It says processing. I think I accidentally pressed the back button while I was doing that, so I got to do it again. Whoops. Oh, that was bad. Yeah, let's try one more time. I have this terrible gaming mouse with extra buttons on the side. Apparently one's set the back button. So I hit it against my keyboard. So let me try one more time. The beginning of a beautiful project. Commit changes. Processing your files. Har har. And there it is. I did it. And if you click on review1.pde, you'll actually see your code in there. And when you go home, you can just log into your GitHub account and you can download it from there as well, and then commit it so that you don't have to email. Man, I felt bad for people that are emailing their code home to themselves. They would copy it into an email, and then when they got here, they'd paste it. You didn't. Some people realized you could zip the whole thing and attach it, but that's a good way to do it. So last thing to do, I see that it's going to be lunchtime. Last thing you're going to do is, if that was successful, great. If you encountered some kind of problem, you can do it next class. It's going to run out of time. But I would love if you could, please, send an email to me right here, lpeltier@vsb.bc.ca, and send me a link to your GitHub account. Just you could even just send me your username would be fine. I can find your account that way. And then I will check. And don't worry, if it didn't happen today, we'll have another chance next class to make it happen. So I can see, that you were able to make it work. If you weren't able to make it work, then just try again next class for whatever reason, and we'll get it to work either today or on Wednesday. If you took advanced programming last year, do this as well, but you might not have done the review because you're working on something else. So you could just make a repository for either a project from last year, or you could make a repository for whatever sketchbook activity you started this morning. And you can send me an email with that being the thing I'll look for. And don't worry about naming anything particular. All right, thanks everybody. Once you've done that, you can head out for lunch. So thanks so much. And if you're having a problem, you can call me over, or you can just do it next time. Your choice. I'll leave it up to you. We don't have to have it done by the end of today. But this will be something we're doing every class. Even when we're working on a project, at the end of the class, I'll stop everything at least 5 minutes early. We'll all do our commits. And that way our code will never get deleted more than one class worth anyways. I can still see someone's power bar getting unplugged and it breaking down or something. But we'll at most lose one day of work. Okay, so if you got a question, let me know. I'll come over and help. Everything good to do? Yeah, that's right. So if you were to drag it up again, it would overwrite it. But you still see what you did. Yeah, there you go. Thanks, Victoria. Oh, congratulations, by the way. I saw from Mr. Ewan that you did incredibly well over the summer. And what was the tournament that you were at? I can't imagine how that was. So, I look forward to hearing more about
yeah, eventually, but I can tell him.
Yeah, sure. Oh, so he was going to upload files, and you might not get to get links right now, but I'll upload that YouTube video. Oh, I should go stop it. And then you can watch it whenever, sometime between now and next class. Yeah, for sure. And I left this video still recording, so I better stop.